So what we need you to do for 5-2 alpha is go to page 325 of your textbook and read the first 4 bullet points. And you are additionally in Canvas going to Google Slides, and you're going to go through the first 40 slides. All right, so for 5-2 alpha, here's where we are. We told you yesterday that probability, the definition of probability is success to total. And then we told you the probability is not interchangeable with odds, because probability has success to total and odds has failure to success. So what's happening is probability omits the failure component and odds omits the total component. So I did look this up, and the probability that the Eagles win the game tonight, as per ESPN, is 7/10. That is success, 7 successes to 10 failures, or 7 successes to 10 games. The odds that the Eagles win would be failure to success, 3-7. Okay? Odds are not an AP topic, but I need you to understand it's not interchangeable with probability. So, probability rules. These symbols you're not familiar with. Okay? So, you don't have to use these symbols. This V is a mathematical abbreviation of OR. If you'd rather write OR, go ahead. So I want the probability of A or B. What is that? That's the sum of the probabilities, take away their intersection. So the easiest way to convey that is with a Venn diagram. So I have these two probabilities. So probability A is that Deshaun Jackson plays tonight in the game. And probability B is that Alshon Jeffrey plays. Are we good? So if I want to know if one or the other plays, you add them up. Except what? If they both play, then this area in here is the intersection. That's they both played in the game. We have to subtract that. We have to subtract it once because it's part of both sets. It's counted in the left circle and the right circle. The sum of the two circles is, like, for example, say it's this. Say the probability that Deshaun Jackson plays, he's supposed to play, is 80%. And the probability that Jeffries plays is 40%. Well, that's over 100%. That can't, right? You can't have over 100%. So the issue is that they both play. It's 32%. And we would have to take that away from the sum. You're not worried about the numbers yet. But you would have to subtract that once, this 32. And you would have 8 plus 40, take away 32. You'd have 88% chance that one of them played, one or the other played. Does that make sense? So the Venn diagram is the easiest way to communicate this. Disjoint. Disjoint is a vocabulary word that you are accountable for. It's not like R squared, which is something you have to memorize, or the difference between an experiment and observation, or the definition of bias. Disjoint just means mutually exclusive. If one event happens, the other can't. So we go up here and we say, suppose you're the Eagles. Deshaun Jackson tells you he's going to play. You tell Alshon Jeffrey, take another game off. Why? Because you got the guy 13. I'm not taking him out. First one of these guys is ready to play, you're in. The other guy's out. I'm not taking the kid out. He's killing it. So they'd be mutually exclusive. It would look like this. Those probabilities. If there is no intersection that can happen, then when we go to take this out, we'd be subtracting 0. There's no overlap. So if you have two events, now it can't be 80 and 40 anymore. It doesn't fit in here. There's only room for 100% in here. So if you had two events that can't happen together, that's disjoint. And this, ready? This V is or, and the inverted V is and. And if it helps you to write, like shorthand symbols for or and, or write the words out, that would be fine. We used to do this in pre-calc, and they got away from it. And, it's not in the book. These are just abbreviations for or and. Okay? But in these problems, if you're unsure, draw a Venn diagram. So we're going to just do 3 questions. And the questions are, to communicate this to you, this is not the most challenging part of the probability. It's just counting, really. 31, 33, and 37. 31, 33, and 37, and we're going to come back and go over that, okay? 31. 31 is about the dice. So we said, okay, if I call one die green, what are the faces? A 1, 2, 3, or 4. The other die's red, 1, 2, 3, or 4. And in these cells would be the sums. So for example, green 2, red 3 is a 5. And the question is, what's the probability of getting a 5? So we just count them. 1, 2, 3, 4 5s out of 4 rows and 4 columns, 4/16. The probability of getting a 5. Many people have the probabilities with 2 6-sided dies memorized, so they gave you just something a little different. 4/16. It doesn't make it wrong to reduce it or write it as a decimal. It's an FRQ. They're all equally correct. However, if it's a multiple choice question and you don't see 1/4, they just didn't reduce it. Okay? Then 33 asks about the 6 grandchildren, and there's 2 tickets for this show. So we just built this array. Now what's happening? I just wrote the children's first initial horizontally and vertically. The child can't attend with themselves. There's 2 of them going. So this CC is out, DD's out, LL's out from there. Then I said, okay, the children going, you want a girl to go. So how could you do this? Well, P is for Piper. She's a girl. So all the Piper row is filled in, except for Piper with Piper. And then S is a girl who is Sedona. The S row is filled in, the P row and the P column and the S column. So then Brian Bradley said, well, yeah, it doesn't really make sense to have these initials on either side of that diagonal. Yeah, order doesn't matter, right? Because if I look here, I have CP, and here's PC. So that got counted twice. But so do all the available cells get counted twice. So it's going to reduce to the same answer. So you could have built your array and just counted these cells which would give you 9 out of 15, or you could count all of them, which has doubles in it, but there's double the number of cells too. That'd be 18 out of 30. So either way, that's the probability, which is 60%, because sometimes it does help you to write as a decimal to quantify it, to make sense of it. A 60% chance that if they do this randomly, that a girl will be included in the trip. Okay? And then the last one is 37, and they give you this table. So for the table, the number of people, now this is a complete table. The number of people in a household, 1, 2, 3, 4, 5, 6, greater than or equal to 7. That's it. It can't be, there's nothing missing. You can't have 0 people in a household. You can't have 1.5 people in a household. If it's a complete set, the sum has to be 1. So they give you some values. Well, they give you all the values except for 2. 0.25, 0.32, 7%, 3%, 1%. And they leave these 2 cells empty. Now, what's implied by those question marks are they the same values? Otherwise, they'd have to have 2 variables there instead of one. It's kind of misleading. Does that make sense? If they made one, they made it X. If they made one X and the other Y, no one can solve an equation with 2 unknowns. So the only way you can do this is say, okay, add up what's given. 68%, the sum of the ones they did give you. How far is that from 1? 32%. So these 2 have to be 16% each to make the sum of the whole thing 1. And it has to be 1 because every possibility is accounted for. The next thing is kind of a user-friendly way of communicating this to you. So they say to you, what is the probability? I lost the book here. What's the probability contains more than 2 people? So more than 2 people is here. So you would add up 1, 2, 3, 4, 5 percentages. But it'd be easier to just add what isn't there. See, and it's not a big deal in this problem because the numbers are user-friendly. But if we had a long array, and we're going to get to more extended probability problems, if they ask us that, it's way easier to say what's missing. So it's everything except for these 2. And these 2 add up to 57%. So what's in the box, which is what you're asked for, must add up to 43%. Does that make sense? That's it. There's nothing more to the 5-2 alpha than that. It gets more involved. It's going to get way more involved. But that's it for 5-2 alpha.